reject a previously held claim. A confidence interval is going to help us zoom in or zero in on where exactly the range of our results lie. We're going to use the same problem we used in a previous video talking about work stress and its negative impact on life. So 75% of restaurant employees say yes, that stress from work does negatively impact their life. And we're taking a random survey from a particular chain of restaurants where 68 of 100 employees say yes, that work stress does negatively impact their life. We did a confidence interval of this earlier and found that there isn't a difference between national chains, but we want to see exactly where the stress level is for this chain. So we're going to do a confidence interval. Now we've done these before, back before we left school, but this is simply a reminder. We're going to skip steps 1 and 2 and jump straight into the calculations. So this is confidence intervals for proportions. Here's our calculations. We're going to start at step 3, calculations. You're prompted to do this in one of the problems in this unit, then we typically can start at step 3 because the question will ask what is the confidence interval, and then it'll ask to interpret that in context. So we're going to be focusing on step 3 and 4. Here's our formula. We're going to take the sample proportion, p hat, plus or minus z star. Now z star tells us how confident are we going to be. This is our test statistic, but it's working in a way that's saying how many standard deviations up, how many standard deviations down to capture a certain percentage of this population. And then times the standard deviation of the sample. Now an observant person will notice that we're using p hat here, the sample population, or sample proportion rather than p sub naught, our hypothesized proportion. In the last video when we were doing a test of our hypothesis, we use p sub naught in our deviation, in our standard deviation. Here we're using the sample proportion. And again, this is because this is the standard deviation of the sample, and in our last problem, it was the standard deviation of the estimate. So let's drop some values in. Let's do a 95% confidence interval. So p hat, that's my sample proportion. Again, that's x divided by n, so really easy, 0.68, plus or minus z star, a 95% confidence interval. You can find on your green sheet, your table C, if I'm looking up a 95% confidence level down to the bottom, we see that's a z star of 1.96. You probably didn't see it, you'll just have to trust me. 1.96 times the standard deviation of my sample, so that's the square root of 0.68. 1 minus 0.68, that's 0.32 over my sample size, whoops, not of n, but of 100. Now, I'm pretty sure that I could mess this up if I put it in my calculator. My parentheses weren't right. Order of operations is going to get wonky on me, and so I'm going to use my TI calculator in order to have it figure out the confidence interval for me. In order to do that, we are going to hit the stat button, over to tests, down to all the way to A, where it says one proportion z interval. One proportion z interval is what I'm after. You're going to whoops, I hit 2 proportion, going back, 1 proportion Z interval, where you're going to enter your X, number of successes, your N, number of trials, your confidence level, 95%, and calculate. And that gives us this guy right here. It says we are between 0.588, I'm going to round to 0.59, and 0.771, I'm going to round 0.77. All right, so we've got our confidence interval. We're going to move on to step 4 and talk about this in context. All right, so I'm leaving the confidence interval that I came up with using my TI calculator right here so we can apply that to the context of the problem. Step 4, context. Because we're doing a confidence interval, we go back to kind of our template for context, and we say, I am blank % confident. And in this case, we are 95% confident. That's the confidence interval we used. 95% confident that the true proportion of, what are we talking about? We're talking about stressed employees at this particular chain is between, here it is, 59 and 77%. I'd like to talk about this for just a second before ending the video. We, in our previous video, did a hypothesis test to see whether or not this particular chain was less than my null hypothesis of 75%. Well, my confidence interval confirms that we are, that 75% is within that. If your confidence interval captures your null hypothesis, then you're going to fail to reject. If my null hypothesis was on the outside of my confidence interval, then we would reject the hypothesis. For example, if I was going from 59 to say my confidence interval was 59 to 73%, then that the whole chunk is less than 75. So that would lend itself to a rejection of the null hypothesis. So you can see the two are linked, especially when we're talking about two-sided null hypotheses, or alternative hypotheses rather. I believe practice problem 12.22 is two-sided, so watch that video to learn a little bit more about that. All right, well, thanks so much.